It's Sunday night, and tomorrow is Monday. Look to your right, and you will see a funny joke about Mondays. My week is basically Monday, Monday number two, Monday number three, Monday number four, Friday, Saturday, and today is pre Monday. Oh. Okay, so today we're going to look at planets. So I'll give you a moment to read this question. I'll read it aloud. Venus has a mass of 4.88 times 10 to the 24 kilograms and a radius of 6,073 kilometers. Now, one thing, I need to do this because, in my tests, I made this big mistake. I didn't convert radius in kilometers to meters. So this is just this many meters. It's really important because you want to make sure that your answer is in the right units. Okay. So, determine the magnitude of Venus's gravitational field. What is a gravitational field? Gravitational field strength is actually just how hard a planet is pulling you down. Like, what is the acceleration? Because we know that it's quite common knowledge that Earth's gravitational field strength is 9.81 meters per second squared. Could also be negative. And yeah, this is basically asking for that. So if you see gravitational field, that's what it means. And this is always in acceleration. So meters per second squared. So if we think about this, like we're a person standing in Mars, well, gravity would be pulling us down, right? So force of gravity. And since we're not on Earth, I mean, it would still be mass. But okay, anyways, the equation for gravity is this. And one really nice thing is that because we know force of gravity is also equal to mass times acceleration, this means that we can already cancel out mass. This is because this means that the gravitational field strength does not matter how heavy the other object is. So like if I'm standing on Earth, right? How hard Earth would be pulling on me, it's basically like, it doesn't matter how heavy I am. Unless I was really, really heavy, then it would matter. But that's also not about. Anyways, I'm not explaining this very well, but you get the idea. So this is our gravitational field strength, G times m over r squared. And we saw that the mass is equal to that. So let's just plug in the numbers and see what we get. So 6.67. I'm not going to write the units because that takes too long. Mass is 4.88 over r squared, which is r squared. It's a lot of numbers. 6073000. 6.07 times 10 to the 1, 2, 3, 4, 5, 6. 10 to the 6 meters. So this should give us, whipping out the calc. For these types of questions, it's really important that you can use your calc well. If you can't use your calc well, a lot of bad things could happen. Yeah, like I just used my calc wrong right there. I pushed in 6.67 instead of 6.07, and that's my punishment. So this is equal to, whoa, I made a mistake, I think. What's going on? Oh, I didn't square it. See? Like these questions are like, they're easy, but it's also easy to get them wrong. So yeah, this is actually equal to 8.8. Oh, what is wrong with me? I need to like 6.073 e6 to the power of 2. I lost a bit of precision there. So that's 8.825, 8.83 meters per second squared. Let me see if that's right. Yes, we are cooking. And the answer is actually, apparently they say it's 8.83 newtons per kilogram. But I think that works out to be the same thing because newtons is equal to what? Mass times acceleration. So that's meters per second squared. Huh? Why is it newtons per kilogram? I don't know. I think I got something wrong with the units there. Oh yeah, I might be a bit dumb. Newtons is not meters per square second. Newtons is kilograms. Ooh, kilograms times meters per square second. And the answer wrote it as that, so we just divided by kilograms, which would give us meters per second squared. Yeah, I don't know. You could write it. You could write the units whichever way you want. I don't think that matters very much. Okay, and B makes it just one extra step, and one more thing to be careful of. So our same thing here. Acceleration is equal to gm over r squared. But this time our radius is changing slightly. So many numbers. What was it? 4.88. And r squared last time was 6.073 times 10 to the 6 meters. And we gotta multiply, we gotta add 3. What is that? 3, 1, 2, 3, 4, 5, 6. 3 times 10 to the 6 meters. And we square that. This is like just a number soup. So many numbers. And I think I got this quiz like, for this topic, I got a really low quiz mark, and it was because of the units. Made bad mistakes with the units. Honestly, yeah, it's like typing it into your calculator takes so long. I don't like this, but it is what it is. Let me square that. It's giving us 3.95 newtons per kilogram or meters per second squared. Great. And yeah, it was asking for magnitude. So yeah. Now, second question. Determine the altitude above the Earth's surface where a satellite experiences a gravitational field strength of 8.72 newtons per kilogram. So they didn't give us any values here because they're assuming that we have the formula sheet. So remember to look at your formula sheet. What do we need here? This is the exact same question as the last one because it's just asking us gravitational field strength. So what was in that formula again? Let's write it one more time. Equals gm over r squared. So what do we need really? We need the mass of the Earth So let's see, mass of the Earth is equal to 5.98 times 10 to the 24 kilograms. And what else? We need radius. Radius is equal to 6.38 times 10 to the 6 meters. Now, that's it. We plug it all in. We know gravitational field strength is 8.72, so let's just put that in right now. Newtons per kilogram or meters per second squared. I'll just write my units this one time, but honestly I won't for the other ones because you know how it all works out anyways, so it's okay. And mass here is 5.98 times 10 to the 24, and the radius, now be careful, we're trying to find the radius. We're trying to find something plus the radius. Honestly, just leave that as r squared for now. So this radius is not the radius of the Earth, it's the radius of the satellite to the center of the Earth. So we're going to have to subtract this value later. So let's just solve for r squared right now. R, I mean. So we would just, do the old switcheroo. We do this over here, do this over here, and we do a little square root sign. Let's see what we get. Negative 11 times 5.98 e24 divided by 8.72, square root that, giving us, oh my god, there are so many 6 7s. 6 7. Today's 6/7, by the way. It's June 6th. It's June 7th. 6/7. Happy 6/7 day. Times 1, 2, 3, 4, 5, 6. 10 to the 6 meters. Okay. And this is going to be added to our other thing, which is, I feel like I'm not doing this right. I might have put something in my calculator wrong. Have I? Or have I not? Because I feel like I'm getting a really big number. It doesn't make very much sense. But, we'll see. So, oh, no, it's all good. It's all good. We're still happy. So, this is the radius. And what else? This is the radius from the center of the Earth to the satellite. And what we want is, what do we want? Huh? We're trying to find the altitude above the Earth's surface, right? So this just means we have to minus this from the actual Earth radius, which equals 6.38 E6 equals 383,247 meters, and we can round this to, wait a minute, I'm getting something wrong. Apparently it says it's 393 kilometers. I don't know. I feel like it's 383 though. We'll see who's right. I don't think I'm getting anything wrong. It's fine. This is a 3.8 times 10 to the 1, 2, 3, 4, 5. 5 meters. 3.83. Let me just double check that real quick. I just did some research and, well, I think it's because my book is using 6.37 times 10 to the 6 meters instead of my 6.38. It depends on what formula sheet you have, I guess. Doesn't really matter, but at least we solved the problem. So, yeah, the answer is 3.83 times 10 to the 5 meters. Okay, next one. Determine the speed at which a satellite must be moving in order to maintain a low orbit 151 kilometers above the Earth, where the gravitational field strength is 9.38 newtons per kilogram. So for this one, we just have to think about the satellite here. You know, the satellite's like a little fly or something, and it's moving all around the Earth, right? So what is the net force acting on this little thing, on this satellite? It's moving in a circle. And why is it not falling toward Earth? I mean, okay, it's moving in a circle, so that means there's centrifugal force, and there's also gravitational force, and they are the same thing. And the reason why the satellite's not falling into the Earth is because it's moving. It's moving at the right velocity. So force centripetal is equal to mass times velocity squared over r, while this is equal to gmm over r squared. And there's a lot of letters. Might as well be English class. But we can cancel out the two. So the satellite, that's why they don't give the mass of the satellite, because the mass actually doesn't affect the speed that it needs to move at. It doesn't matter. So v squared over r is equal to gm over r squared. And if we rearrange everything, we're trying to find the speed. So v squared equals gm over r, because this r and this r cancels out, right? And in the end we get v equals gm over r. Okay, and I just realized I don't think you really need this for this problem. Also, I don't think this one really works out that well, because you need your gravitational field strength. You need to factor that one in. So yeah, I don't think this one really works, because there's nowhere to put that in. This equation would be more useful when? I don't know. I'm very tired. Gm over r. Anyways, more useful one here is that we're equating Fc with Fg. So mv squared over r is equal to mg. And these two cancel out, so v squared over r equals g. V equals root gr. So we know now. Let's first convert this to meters, and we need to find the speed. So velocity equals root, and here's where we can use 9.38 meters per second squared times our radius of 1.51 times 10 to the 5 meters, which equals root 9.38 times 1.51 E5. What am I doing? Getting some really weird numbers. Today is so weird. What's going on? One, two, three, four, five. Because that does not look like the right answer. Oh wow. This is an aura loss. Oh yeah, I'm not being auriful because that's not our radius. That's only one part of our radius. we have to add our Earth radius, the radius of our Earth, to actually have the radius of our orbit. So 1.51 E5 plus 6.38 E6. Honestly, that's like that's like a drop in the bucket. You know, you probably got the same answer even if you didn't add that, which is pretty funny. But also you should add it anyways. And that gives us a more familiar answer of 7826 meters per second. So that's also equal to 7.83 kilometers per second, or 7.83 times 10 to the 3 meters per second. Doesn't really matter, but here you go. This is the final answer. Last question, finally. Calculate the speed required for a satellite to remain in a circular orbit 300 kilometers above the Earth's surface. So, what was wrong with the equation I did earlier? This one. Well, this one, like, we already were given the gravitational thing, right? Here we're still trying to solve for it. So this is our gravitational field strength, remember? Because acceleration equals gm over r. So this is really just v equals square root of gm over r. Huh? Oh. I'm already a bit confused. Like, I'm confusing myself. But like this was our acceleration, right? That's how we found acceleration in these two. Like that's how we found gravitational field strength. You see here. It's the same thing here, except what is different was that there was an r squared here. Yeah, there's an r squared here, so that was equal to acceleration. But now velocity is equal to just this with an r on the bottom. So that means that acceleration was meters per second squared, right? And there was an extra r on the bottom, so that would cancel out. You know what? It's fine. You know what? Like, honestly, I'm getting confused now. I'm gonna have to look at that later. But anyway, that's kind of dumb. It's not really relevant. But so now we can use this because, you know, this formula here we're calculating. We're trying to calculate the actual gravitational field strength. In this question here, we already had it, so we didn't need to do that, but now we do have to do that. So what was that formula? V equals root gm over r. Nice. And so now let's just plug in our things. There's 6.67 times 10 to the negative 11 over a mass of 5.98. I'm such a bum. I already remember all these values now, which is, I don't know. Why do I remember that? 6.38 times 10 to the 6 meters, but we have to add in these 300 kilometers plus 3 times 10 to the 5 meters. And no need for a square here because we're just looking for velocity. So if we do, this takes so long. It's not even like, I don't like this. Square root that. Get your final answer of 7.73 times 10 to the 3 meters per second. Final answer. So that is the speed required. So yeah, I made a lot of mistakes in this video, but part of learning is mistakes. Okay, I hope you have a great day.